Hey geometry kids, we are on lesson 7-6, which means we're almost to the end of chapter 7. 7-6 is about similarity transformation, so we're going to be looking at graphs, drawing graphs, and looking at how they transform. Now, unlike the last time we did transformations, we are not talking about reflections, rotations, and translations. We are talking about a transformation called a dilation, which means to make it bigger, which is an enlargement, or to make it smaller, which is called a reduction. You will need two colors for this assignment because usually you will see the original shape in one color and then the enlargement or the reduction in a different color. So help your math teacher out, and when you do your homework, use two different colors so I can tell which is the original and which is the dilation. Alright, let's get started. It tells you in example 1 to determine or find out which is an enlargement and which is a reduction. Now it tells you that you're going from A to B. So figure A is the original figure. So if you look at your notes, that's the green triangle. So did the green triangle become bigger or smaller when it became shape B? So look at green to blue, and you should see that this green triangle got a whole lot smaller. So we call that a reduction. Now it asks you to also find the scale factor. So remember, scale factor is a ratio of the side lengths. So if I look at this side on my original triangle A, I can count and it has a length of 4 units. If I look at the dilated image, the same corresponding side, it has a length of 2 units. So to find the scale factor, I need to know, is this going to be 4 over 2 or 2 over 4? To answer that, I need to see, well, what was it? It was a reduction. So if it's a reduction, it means it got smaller. It means the scale factor is smaller than 1. So my scale factor, I'm going to actually put the dilated image, the 2, over the original image, 4. Okay, and it's always that way. The dilated image is always on top. If I reduce that, that gives me a scale factor of 1/2. That means that the dilated image is 1/2 times as large. Let's try letter B. Letter B, my original shape is this blue rectangle. This tiny little rectangle. My dilated image is this much larger rectangle. So since it got larger, we call that an enlargement. I need to find the scale factor. So remember, it's the dilated image over the original. So I'm going to pick this side again. And this side is 3 units, whereas the original image corresponding side is only 1. So let's write it as a ratio of 3 to 1. I need to reduce that, which is 3. What that means is the green rectangle is 3 times larger. Okay? So let's talk a little bit more about scale factor and how we can use it. If you've ever made copies at school, you can know that trying to enlarge or reduce something can be challenging if you don't know the math behind it. So here's a good example of when will I ever need this. You'll need it to make copies if you ever need to. And almost every job needs a copy made at some point. So here we have a receipt that's 1.5 inches wide and 4 inches long. We want to enlarge it so that it is twice as big, okay? So if you think about that, the scale factor is 2. It's twice as big. So instead of it being 1.5 inches wide, it's going to be twice as wide. So now it's 3 inches wide. And it's also going to be twice as long. So instead of 4 inches long, it's going to be 8 inches long. Okay, so there's part of our answer. It also tells us by what percent. So if I want it twice as big, if you think about in terms of percent, 100% is the same size. So if I want it twice, that's going to be 200%. Basically, you're taking your scale factor and moving the decimal point 2 times. So 200% larger. Alright, for example 3, this is where you're going to need your colors. We're going to graph the original, and I'm going to graph it in green. So my original shape is -6, -3, 6, -3, and -6, 6. I'm going to connect those dots. You may want to use a ruler if you do not draw straight. And I'm going to label my points. This is going to be A, B, and C, just so it'll be easier when we have to verify. And we're going to graph the image or the dilation. I'm going to graph it in orange. So we have -2, 1, 2, -1, and -2, 2. Oops, that's this one. Okay, I am going to label this triangle D, E, and F. Okay, so I can see that obviously they're both triangles, but in order to be similar, remember you have to use the either angle, side, or side similarity theorems to prove it. So first of all, is this what would be easiest? I see right here that angle B is a right angle. And I also see angle E is also a right angle. So right there is one thing. Angle B and angle E are right angles. And how do I know that? I know that because the slope of AB is undefined and the slope of BC is 0. They are negative reciprocals, so therefore it is a right angle. Or you could say that these two lines are perpendicular, therefore it is a right angle. The easiest way to prove these are similar is actually going to be side angle side. We have not learned yet how to find the degrees of angle A or C, so we're going to use it by finding the lengths of this two legs here and proving that they are proportional. So we need to prove is AB over DE, is that proportional to BC over EF? So let's find the distance of AB, which is quite simple since it's vertical. We can just count the boxes. If you count the boxes, it's 9. Let's find the distance of DE. Count these boxes, and you'll find that it's 3. Let's find the distance of the other legs. BC is 12, and the distance of EF is 4. So let's plug these numbers in up here and see. Is 9 over 3 proportional to 12 over 4? Let's check. Cross multiply. 9 times 4 is 36. 12 times 3 is also 36. So yes. So by side, angle, side, we know that triangle ABC is similar to triangle DEF. And here's my proof. I need to see that verification on homework. I don't want to just see a yes or a no. Alright? Okay, let's do our last example. I'm going to plot the original in green. So we've got 2, 1, 4, 1, 2, 0, and 4, 0. This tiny little rectangle right here. That's the original. Let's plot the image. I'm going to do it in orange again. We've got 4, 2, 8, 2, and I'm sorry, there's not enough room, so just add it right over there. 4, 0, and 8, 0. So this little rectangle right next door. I want to prove that these are similarity. So I cannot use any of my theorems because these are not triangles. So what I am going to do is see that the scale factor between the two sides is the same. I'm going to see, is this scale factor from this side the same as the scale factor as the bottom two sides? And if they are, then these are similar. So let's see. This side is 1 unit tall. This side is 2. So my scale factor is 2. Let's check the bottom. The bottom of this green one is 2 units long, and the bottom of the orange is 4. So let's see if those scale factor is the same. We have 4 over 2, and that is also 2. So because these are the same, these are similar. And this is an enlargement. And yes, they are similar because the scale factor is the same.